starting with the mean, or the expected value. Pretty simple, actually. It's just the full integral over the full domain of x times f of x. So if your function is this truncus over here, and you want to find the expected value, or the mean, all you're doing is taking that function into an integral and then multiplying it by x. Boundaries in this case are 1 to 2 because that's what the effective domain of our probability density function is. Next up, median and or percentiles. So this is something that's pretty much exclusive to continuous probability. We don't look at this for discrete. The median is you actually solving the middle value of your data set, and it's got to account for a total of half of total probability in your given scenario. So if you want to find the median, what you're essentially doing is solving for the upper bound such that your total area under curve is equal to a half. The median is a specific percentile, it's the 50th percentile. So if a typical question is asking you for like the 70th percentile or whatever, basically whatever the number is they give you is the decimal that you use to equate your integral to. We've seen a question like this before, which was worded purely using a math notation. Here's a version which is worded just purely worded, right? So you have your duration of sales calls given by this particular function. Find the value of a such that 90% of phone calls last less than a minute. This would be effectively the 90th percentile. Find the value of a such that 90% of phone calls last less than a minute. Less than means a is the upper bound, and so you want to go from your upper bound all the way to the absolute lower bound, in this case 0. And because you want to find it such that 90% of phone calls last less than, you're now using 0.9 as the thing that you are equating to. Sub in, simplify, 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 you'll get some logarithm answer. Next up, variance. That term there is the mean, it's the expected value, so what you're going to want to do is evaluate the expected value first before you then go ahead and try to evaluate the full thing. So you do expected value, x times f of x, put it in the spot where the mean, where the expected value goes, and then once again evaluate via the cas. Second to last is going to be the standard deviation. Standard deviation is always the square root of variance. So we already had a look at variance, it's just that equation. So if you want to find the standard deviation, you are just square rooting. Last one up, this is the interquartile range. This is technically nothing new. This is just you finding two specific percentiles and then performing a subtraction. That's it. It's the distance between the 25th and the 75th percentile. So you equate your integral to 0.25, solve the upper bound. You equate your integral to 0.75, solve the upper bound. Take those two values, perform a subtraction between them, and whatever comes out is your interquartile range.